Well, hey everybody, Mr. Reeves back with you, and in this video today we're going to be looking at lesson 18.1 in the Math 7 Accelerated textbook, solving equations with variables on both sides. All right, so we have been solving, well, first we solved one-step equations, then we solved two-step equations, and now we're going to solve equations that have variables on both sides. So I'd like to start off by with a few visual examples. And one way we can look at solving an equation with a variable on both sides is using a balance. All right, for those of you who may not be familiar with a balance, you put weights on each side, and if the amount of weight is the same on each side, then the balance is perfectly horizontal. So right now you can see that this balance is perfectly horizontal. Let me unbalance it. I'm going to go ahead and take one off here and put it in the trash, and you'll see now it went down on the left. That means that the left side is heavier, right? So if I now put this one back on, now they're balanced. Now if I take one off here, now the right side is heavier. All right, so this represents, whoops, didn't mean for that to happen. This represents an equation, right? Because you can see we have an equal sign. The weight on the left and the weight on the right, they are balanced, so these have equal value. So our goal is to find the value of x. Just like when we're solving any equation, the goal is to find the value of x that makes the equation true. Or in this case, the number of blocks, these 1 blocks that balance with 1x blocks. Okay. Now remember, we talked about those properties of equalities. You can add, subtract, multiply, or divide to both sides of the equation. As long as you do the same thing to both sides of an equation, you're going to be good. It will be a true equation. Remember, though, we don't multiply by 0 because that would wipe the entire equation out. And we don't divide by 0 because that's just not allowed. All right, so if my goal is to find out what the value of x is, as long as I do it to both sides, I'm okay. I can do anything I want to. So, for example, I can go ahead and add one more to each side, all right? And it's balanced, right? But did that help me get closer to the answer? Now I have 2x plus 8 equals 3x plus 5. It's still true, but it's not any closer. So actually, I don't want to focus on adding here. It's about what I can take away. All right? So for example, if I take away what I just added on, now they're balanced. All right? No, now they're balanced. There we go. There we go. All right, so by the way, you'll notice everything we have here is positive. We're going to do an example in just a minute that has a negative. So I can take away, I can start by taking away 1s from each side, or I can take away x's from each side. My recommendation to you is going to be to start with the variable terms. Start by solving an equation with variables on both sides. Start by working with the variable terms. And I'm going to go ahead and flip these over like this. All right. Okay, now I have 2x's here and I have 3x's here. So my recommendation to you, and again, you can do it in any order you want to, and you could do anything you want to, as long as you do it to both sides. Okay, what is going to be most efficient? All right, what's going to be the easiest to work with? That's my point of view. And I'm going to say start with the variable term that has a smaller coefficient. So what do I have here? I have 2x's, and here I have 3x's. So I'm going to start by taking away x's. So I'm going to take away 1x on this side. All right, and then I'm going to take away 1x on this side. Then I'm going to take away 1x on this side. And then I'm going to take away 1x on this side. All right, you'll notice now there's no x's over here. All right, so what did I start off with? I started off with 2x's and 3x's, and what did I do? I took away 2x's from each side. All right, so in fact, let me just go ahead right now. Let's see if it's going to let me right here. There we go. I had 2x, okay, plus 7 was equal to 3x plus 4. And what did I do? I took away 2x's from each side. And when I did that, what's left? Well, now I have 7 equals x plus 4. So do you see that right here? I have 7 here, 1, 2, 3, 4, 5, 6, 7, and here I have x and 4, or x plus 4. All right? Okay, so now what am I going to do? Well, now again, my goal is to get the variable by itself. So now really what I have is a two-step equation, right? Let me go back to where we just were. I have a two-step equation. Actually, I have a one-step equation because the coefficient there is 1. So what would I do? All right, well, if you were solving this on paper, you would take away 4 from each side, wouldn't you? And you would get 3 is equal to x. Isn't that what you would get? Okay, well, let's do that here. Let's take away 4 from each side. Now, again, I'm taking away the smaller amount here. Actually, now what I'm trying to do is actually just get this variable by itself. So I'm going to take away 1 there, gone, 1 there, gone. Now it's balanced again, right? 1 there, gone, 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 goner, gonest. And then what's my answer? Do you see how it's fully balanced? 1x is equal to 3. So actually this one says 3 is equal to x, right? But we know that that's the same as, do we know? It's called the reflexive property. 3 is equal to x, or x is equal to 3. All right? Okay, so that's an example of solving an equation with variables on both sides using a balance. We can also use algebra tiles. All right, so if I take a look at this equation right here, what do I have? I have 2x plus 1, 2, 3, 4, 5. 2x plus 5 is equal to x plus negative 1, right? Or usually what we write is x minus 1. So my goal is to solve this equation. Now remember what I said. My recommendation is to start with the variables and take away the one that has the smaller coefficient. In this case, I have 2x's here and 1x here. So my recommendation at the beginning right here, I'm going to take away 1x here and take away 1x here. All right, so if we look at what we had, let's go back, we had 2x plus 5 equals x minus 1. What did I do? I took away 1x from each side. And when I did that, what's left? X plus 5 is equal to negative 1, right? What do I have right here? I have x plus 5 is equal to negative 1. All right, now you guys know what we would do next, right? Our goal is to get that x by itself. So what would we do? We would take away 5 from each side, wouldn't we? We'd want to take away 5 from each side. The problem is what? I don't have 5 to take away here, do I? All right. So what about instead if I added a negative 5 to both sides? Right? Add a negative 5 to both sides because we're working with algebra tiles. So that's what I'm going to go ahead and do. My goal is to get the x by itself. So I'm going to go 1, 2, 3, 4, 5, right? 1, 2. Uh-oh, I'm out, so I'm going to have to do some copying here. All right, where's the copy? Copy. Oh, here it is. Okay, there we go. 1, 2, 3, 4, 5. Let me try to make them look alike so you can see that I did the same thing to both sides, right? I did the same thing to both sides. All right, I know it's not exactly the same, but it's okay, right? You could see I did the same thing to both sides. Now, what's going to happen with these? They're going to cancel. Go away, go away. Gone. And what do I now have? I have x equals negative 6. X equals negative 6. So if we go back in time here to where we were, what I did was I added negative 5, but that's the same as subtracting 5, right? Because adding 5 negatives is equivalent to subtracting 5. So I did that, and I get x is equal to negative 6. By the way, I did not do it in the last one, and I should have. We can check our answer and make sure that our answer is correct. So 2 times negative 6 is negative 12 plus 5. And negative 12 plus 5 is equal to negative 7. And negative 6 minus 1 is also negative 7. It checks, okay? And if we go, can we go back to our balance one here? Here we go. So we had our original equation, 2x plus 7 equals 3x plus 4. If we check it, 2 times 3 plus 7. Does that equal 3 times 3 plus 4? Well, 2 times 3 is 6. 6 plus 7 is 13. And 3 times 3 is 9, and 9 plus 4 is 13. So anytime you solve an equation, it's a really good idea to take that answer and plug it back in. And if you get a true equation, that means that your solution is correct. And if you get a false equation, which happens sometimes to me because I made a mistake, then I got to go back and see where was my mistake. Okay, so that was an example we did with algebra tiles. All right, we also did an example with a balance. And then, of course, many times you're simply going to be doing the problems using paper and pencil. All right, so let's do some problems. These are from the guided practice on page 562. All right, let's start with number 3 right here. All right, I'm going to go ahead and make some space at the bottom here. So I'm doing this problem right here. I'm going to rewrite it. B plus 4 is equal to 2b minus 5. So again, I have variables on both sides. So my recommendation to you, find the variable terms. There they are, b and 2b. Find the one that has the smaller coefficient. Well, the coefficient on this one is 1. The coefficient on this one is 2. Find the one with the smaller coefficient and take it away. Minus 1b. Minus 1b. And when I do that, I get 4 is equal to b minus 5. All right, so now I have, in this case, just a one-step equation. Many times it will be a two-step equation. Now, my goal is to get that variable by itself. The opposite operations in the opposite order, those cancel. We get b is equal to 9, right? And if we check it, 9 plus 4, does that equal to 2 times 9 minus 5? Well, 9 plus 4 is 13. 18 minus 5 is 13. 13 equals 13. It checks, so that means that my answer was correct. Woohoo! Woohoo! Okay, all right. What about number 4 here? Let's do number 4 here. All right, number 4, what do we have? We have 10h plus 12 equals 8h plus 4. Okay, so again, I'm going to find my variable terms. I'm going to say which one has the smaller coefficient. Well, 8 is smaller than 10, so I'm going to take away 8 h's from both sides. Remember, whatever you do, you always do it to both sides. Well, 10 h's take away 8 h's is 2 h's. 2 h's plus 12 is equal to 4. Now I have a two-step equation, right? My goal is to get that variable by itself. The opposite operations in the opposite order, I take away 12 from each side. 2h is equal to negative 8. I divide by 2. I get h is equal to negative 4. Let's check it. 10 times negative 4 plus 12. Does that equal 8 times negative 4 plus 4? Well, 10 times negative 4, negative 40 plus 12. Let's see here. That's going to give me negative 28. Negative 8 times 4, that's negative 32. Negative 30 plus 4, negative 28. It checks. So what does that mean about my answer? That means it is correct. Yay. Okay, let's do one that has a negative variable. How about this one, number 5 right here? All right, number 5, if we do this one, what do we have? We have negative 6x minus 29 equals 5x minus 7. Now, again, my recommendation is find the variable term that has the smaller coefficient. Now, this is where it gets a little bit tricky, because if I say what's smaller, 5 or 6, right? 5 is smaller. But if I say what's smaller, negative 6 or negative 5, negative 6 is smaller. So remember what I said, take away the smaller one from both sides. Take away the smaller one from both sides, all right? But subtracting a negative is what? Subtracting a negative is the same as adding a positive. So usually when we have a negative coefficient, we don't subtract it away. We simply add the opposite, right? So it's minus 6x, so I'm going to add 6x to both sides. All right, it would be like I had 6 red squares and I added 6 yellow squares. They cancel. All right, so what am I left with? Negative 29 is equal to what? 11x minus 7. And now what do I have? Now I have a two-step equation. The opposite operations in the opposite order. Go ahead and add 7 to both sides. Negative 22 is equal to 11x. Divide by 11. Negative 2 is equal to x. Okay, let's check it. Negative 6 times negative 2 minus 29 equals 5 times negative 2 minus 7. I get 12 minus 29 equals negative 10 minus 7. Well, 12 minus 29, let's see what I get there. That's negative 17 equals negative 17. It checks, so that means that my answer was correct. Okay. All right, so that is how you solve two-step equations. Again, as long as you do it to both sides, you can do it in whatever order you want to. All right, instead of subtracting 8 h's from both sides, we could have subtracted 10 h's from both sides, right? Instead of subtracting 4, we could subtract 12. Or you can do it in any order you want to, doing anything you want to both sides. Find the way that is easiest for you and fastest for you. I think that my recommendation is a pretty good one, that you take away the variable term first, the smaller variable term from both sides, because when you do that, it will always lead to either a one-step equation or a two-step equation, and then you can go from there. All right, I hope this video was helpful for you. As always, if you have more questions, feel free to email me and let me know. Happy to help. Have a great day. Bye.